When you think about what you do as a developer, certainly querying and manipulating data has always been a fundamental part of what you do. The data formats change over the years. I've been doing this for 25 years, and things have changed, but the core needs are always the same. If you think back to 1985 or so, back when we used DBase as the language for querying data, you might have seen a query like this. That is, a language, DBase was a language, which allowed you to specify queries directly in the language itself. Of course, there was no IntelliSense or compilers back then for this sort of thing, but you still can see that the language itself defined the type of query that you might create. Moving ahead to the world of .NET, you might see code like this when .NET first came out. Now you notice in here that any command text you want to write is just a string, so that it's up to you to make sure that the syntax is correct. In addition, working with parameters, it's just strings. You create a connection, you open the connection, you execute a command, and then you iterate through the data that comes back. And certainly, this technique worked, and it was very familiar for those coming in from earlier non-managed data access techniques. Now, over the last few years, previous to the current years that is, object relational mapping has become a feature of various tools. Now in C# you might see code like this that allows you to express a map between data and code. That is, you create a class, in this case maybe named employee, and this class then gets filled in with data, somehow or other, maybe magically, and your code then just iterates through instances of this class rather than dealing with the data directly. This abstraction distances you from the structure of the data, so should the schema change, your code might not have to change, and this is a benefit. This object relational mapping provides for a mapping between relational data to and from objects. That means that you use your instances of classes to get the data from the database, make your changes, and then some sort of magic layer shoves the data back out to the database. It provides a cleaner integration of business rules and validation. And so this technique using an object relational mapping, that's kind of the concept behind the typed data set in .NET, has become very popular. But challenges still remain. How do you retrieve non-relational data? Maybe you want to work with XML data or data coming from an RSS feed, data retrieved from a web service or a REST service, Active Directory. Maybe you have to interact with files in the file system or other non-relational data. Well, object relational mapping really isn't meant for that sort of behavior. And what if you want to interact with plain old objects? Maybe you have a collection of some sort of object and you'd like some general way to iterate through or search for instances of objects with certain properties set. How do you interact and query custom domain models that don't have a mapping to some database? How do you enable clean code, that is, code that works easily and is maintainable in both a strongly typed and a dynamic language world? As time goes on, languages are moving more to a dynamic model. The answer, for now, is LINQ, that is, Language Integrated Query. This provides query, set, and transform operations for .NET built right into the language. It makes querying data a core programming concept, part of the language itself. And it works with all types and shapes of data. It works with relational databases. That's where you're most likely to use it, but it works in other situations as well, and we'll actually start with other situations. It works with XML. There is a version of LINQ that talks directly with XML data. And you can use LINQ to query just plain old collections of objects. It provides an exciting new way to retrieve data about objects that you might have otherwise written iterative code to work out. LINQ works with all .NET languages, and VB and C# have integrated language support, meaning the LINQ methods are sometimes wrapped up in language keywords. You can always get to the LINQ methods, but VB and C# have special integrated language support. It works with both Windows and web applications. And you can also find third-party link providers. Amazon.com, for example, has written a link provider so you can use LINQ over Amazon.com's data directly. Now let's think about how LINQ and languages interact together. LINQ and languages allow you to write your data access code directly. You get compile time, syntax, and schema checking, and you get IntelliSense too against the schema of your data. There's no need to create a query as a string, then wait until runtime to see if it includes the correct field names and the correct syntax. Instead, the LINQ data access code is abstracted from the underlying data. You get a consistent syntax across all different data sources. LINQ looks like LINQ no matter where you use it, and you can join information from different sources. Basically, LINQ makes it much easier for you to create queries in your code. In order for LINQ to work with languages and their built-in features, there are some required language changes. We'll look at all of these as we work through LINQ examples. First of all, query expressions. We need some way to define the query and what data it should retrieve. Anonymous types allow you to define a type inline in the query, because sometimes you have no reason or cannot create ahead of time a type that defines the data you want to retrieve. Extension methods allow you to extend an existing class in the .NET framework even if you can't inherit from that class, if the class is sealed. Lambda expressions are, well, to C# developers, like little anonymous methods. To Visual Basic developers, this is a brand new concept, that you have a method that you describe in line in your query. We'll see examples of this later on. Implicitly typed local variables. This is great for queries because it means you don't have to specify the type of a return type of a query, because often you won't know. There's no way to know ahead of time what data type your query returns. But it also means that in general code, you can often get away with not specifying the type of a variable and allow the compiler to do it. It sounds like this is an evil thing, but actually it saves you from some typing when it's obvious by looking at the code what the data type is going to be anyway. Object initializers allow you to specify the initial values of properties of objects even if the constructor for that object doesn't allow you to specify any values. It's a great way to set the value of properties of objects for any object. It's required for LINQ, but it's useful elsewhere as well. Visual Basic and C# both add all these language features, and each of them has a few tricks of their own up their sleeves as well. Now, built into Visual Studio 2008, there are a number of different ways to use LINQ. You can use LINQ to objects. This allows you to iterate over any collection that implements IEnumerable and retrieve data easily, so you don't have to write code that actually loop through the objects looking for things. LINQ will do that for you. It makes any collection of objects a data source. I love this feature and use it often because it really simplifies code. We'll see a few examples of that. We can use LINQ to relational data. For example, LINQ to dataset. There's also LINQ to entities, which is not part of Visual Studio 2008. It's an additional piece which ships after the release of Visual Studio 2008. We won't cover that in this course because we're focusing on core language features in this course. There's also LINQ to SQL, which allows us to query SQL Server data. There's also LINQ to XML, which makes a better XML DOM. That is, it's a replacement or an addition to the XML document object model. To finish up our overview, let's take a look at a graphic representation. Now, if you think about the LINQ-enabled data sources, we have LINQ to objects, which communicates with objects. We have LINQ-enabled ADO.NET, which talks to datasets, to SQL, or to entities. And we have LINQ to XML, which works with XML data. Now, above that, we have .NET Language Integrated Query, which is the language layer which allows Visual Basic, C# and other languages to communicate directly with those LINQ-enabled data sources. Well, enough talking about it. Let's actually dig in and look at some of the syntax. The general format of a LINQ query looks something like this. We start with the from statement. Every query has a from statement specifying where we're getting the data from. You can have a where clause indicating some criteria on that data, an order by clause indicating how you want to order the data, and you'll end with a select statement which indicates what subset of fields you'd like to retrieve, or maybe all of them. Why is that select clause last? Well, think about it. There has to be some way for IntelliSense to know, as you're typing, what fields you could possibly choose when you say select field name at the end. Well, if you didn't have it last, there'd be no way for the IntelliSense to know that. So to make it easier for you to type these LINQ queries, the designers of LINQ decided to put the select clause at the end. If the select clause appeared at the beginning of the query, there would be no way to determine the data source for the IntelliSense and to list for you the appropriate fields. So a simple query might look something like this. Imagine you have an array of integers. In this case, 1, 5, 3, 6, and so on, named numbers. Now I'd like to retrieve from that array a separate data structure with a list of numbers that are in that array that are odd in descending order. Well, there's lots of ways I could do that, but notice how LINQ lets you do it. We declare a variable, odd numbers, using the new keyword var, which doesn't require you to specify the data type. It allows the compiler to implicitly infer the data type from the LINQ query. Here we have a from statement which says from number in numbers. What does that mean, number? What is number? It's an iterating variable. It acts as an iterator that loops through all the values in numbers. You have to specify a name for that so you can refer to it in other clauses. Here, where number modulus 2 does not equal 0 will give us the odd values. Order by number descending, well, that orders by the number in descending order. Finally, the select statement, which says what value you want to retrieve, and in this case, it's just that value number. Let's run the demonstration and convince ourselves that it works. I've loaded the sample project, and here I'll click the first button to run the procedure that includes the query you just saw, which starts out by creating our array of numbers, and then we have our query which retrieves just the odd numbers. Now this code, you'll notice, doesn't define the type for odd numbers, and if I run the query, full speed, there we go, you can see that it tells us that this is an ordered enumerable of int, comma, int, and we don't really need to care what the data type is. Our code needs to keep track of the fact that it is a collection of integers. It has to be because we started with an array of integers. And you can see here that to iterate through that collection, we can use any sort of loop. I'll use a for each loop using an int to visit each value in turn, writing it out to an output stream. As I iterate through, we'll visit each one in turn, and it will end up by displaying the output in a form, and you'll see that we get the odd numbers in descending order, as we should. Now let's go back and look and see how IntelliSense helps you create these queries. Let's create the same query again, var x equals, and now let's start typing. From, I better get my caps lock key fixed up, number in numbers, where, and the keywords for the LINQ query are part of the IntelliSense that we get. Number, there's number, modulus 2 does not equal 0, order by, again, is right there in the IntelliSense list, number, descending, and so on. So you can see that IntelliSense helps you create this LINQ query. You still need to understand the syntax, but once you've sort of internalized the syntax, IntelliSense will help guide you through as you create the query. We've investigated the first language extension that's required for LINQ, that is, writing queries in the language. The next feature that's required is extension methods. Extension methods allow you to add new methods to existing classes. Now, Although this is crucial for LINQ, it's not just for LINQ, and you'll see in our example now that we can add our own methods to built-in classes, but this is the basis of working with LINQ internally. They're always defining a class and then later on adding extension methods to it, which might exist in other classes or even other namespaces outside of that class. Extension methods that you create must be declared as public methods. They must accept a parameter, and the parameter they accept must be of the type of the class that you're attempting to extend. For example, if you want to add a method that extends the string class, your method has to accept a parameter which is a string. The method must exist within a static class. It must be a static method, and it must include the this keyword in the parameter. That is, the this keyword will be applied to the parameter that defines the type of the class you're extending. Let's look at a simple example of this. What if you want to add a method to the system.int32 class, an integer? You want to be able to determine if the integer is odd or even. Maybe you want to add an isOdd and an isEven method to the integer class, so you can easily tell if an integer is odd or even without having to write that code every time. You can create an extension method. Now you can call this extension method either as a method of a particular instance or as a method of the class passing a specific instance, whichever one is more convenient for you. In LINQ, you generally call your extension method as a method of an instance of the class. Now it's pretty clear once you look at this why this is required for LINQ. If you think about it, all LINQ is a series of classes with its own methods. But we see it in the language syntax as a where clause or an order by clause. Well, that where clause represents, once it compiles down to IL, it represents a where method on the query class. Let's look at a demo that shows off creating these extension methods. Our next example uses this isOdd method of the number class. Isn't that interesting? Where did that isOdd method come from? There is no isOdd method on an integer. Well, if we look at this extensions class where I've put some extension methods, in here I have a static class named extensions. It has to be static. I have a public static method, returns a Boolean value named isOdd. The type of the parameter that you pass to this method indicates the class you will be extending, and the this keyword indicates that it is an extension method. That's the important thing. If you leave the this keyword off, you won't see it as an extension method. I provided an isEven and isOdd. IsEven checks the value modulus 2 to see if it equals 0, and isOdd just returns the opposite of that. Now back in our code, here, you'll see that we even get IntelliSense for this. If I type dot is, even, and isOdd show up as if they were built into the integer class. You do see the word extension there, indicating that this is an extension method. There we go. So we should be able to use this rather than explicitly indicating here in the query that we only want odd values by performing the calculation here. Obviously, the results will be exactly the same. I guess I can prove that to you by running it. Here we are. I'll run it full speed, and we'll get the same results. Notice this time I didn't order by the value descending. I just took the order. Oh, this time I ordered by the number ascending, by not specifying that it was descending. In any case, using extension methods allows you to create queries that work a little simpler. But under the covers, LINQ uses extension methods in its own mechanisms to make the query language within C# more extensible. Of course, you're unlikely to want to iterate over an array of integers very often using LINQ. Most likely, you'll be working with more complex collections, but it's really no more difficult, and this offers some new behavior for us to investigate. In our example, I've created a class named Actor. An actor has properties like first name, last name, country, birth date. Very simple class. What if you want to create a new instance of that actor class and provide values for those properties? So what if your class exposes properties but doesn't provide a constructor to initialize them? For example, our actor class. We'd like to create an instance of our actor and add that actor to a collection of actors. Well, there's no new information on this slide. We say actor A equals new actor. Now, I could have used the var keyword rather than the actor type definition there. Either one would have worked fine, and you can see that using the var keyword would not have provided any loss of information, because on the right-hand side of that equal sign, it's pretty clear we're creating a new actor. So why type that name twice? Well, for the word actor, who cares? But for a long type name with a path and a namespace, it would be quite beneficial not to have to type that long name twice. In this case, it doesn't matter. I specify values for each of the properties that I care to specify. In this case, that's all of them. And then add A, our new actor, to our collection of actors. So there's really no new information on this slide. But there's a new way to do it thanks to LINQ. LINQ requires the ability to create objects on the fly and specify values as you create them, and so you get to use that anywhere in the language. Here, we're going to add a new actor to our collection of actors all in one line of code without having to create a new variable for that actor. We say actors.add, new actor, just like you might have done before, except in previous iterations of the language, you couldn't then specify property values at that same time, unless the constructor had that built in. But here we can specify in curly braces, property name equals value, comma, property name equals value, and so on, for each of the properties we'd like to set. If you don't specify the value for a property, then C# assigns that property its default value, an empty string for a string, and a 0 for an integer, and false for booleans, and so on. But once this code runs, we've added a new actor to our collection without creating a separate variable for it, and we've specified values for all the properties of that actor as well. Now, LINQ uses the same technology to allow you to create, as part of a query, a new instance of an object without having to create that object somewhere outside the query, where it really wouldn't make any sense. Here's the actor class, and you'll notice right away there's this cool new feature in C#, which is automatic properties. If you're just creating a property which exposes the value of some internal variable, which lots of properties do, you don't even need to specify that variable. Just say get, semicolon, set, semicolon, and they do all the work for you. It's the little things that make life better. It's not a big deal. No one ever died from typing all that code, but this certainly is simpler. And we have first name, last name, birth date, and country. Of course, just to discuss this a moment, if you want a read-only property, then you just don't put the set. I mean, it's just like any other property. Now, if we run the code that uses this class, here, you'll see the first thing we do is fill the actor list. Let's step into that procedure, which starts by creating a list of actors. And as you've seen, we create a new actor, the old way of doing this, and we initialize each property individually and add the actor to the collection of actors. As the comment says, there must be an easier way to do it, and there is, object initializers. Here, as you saw on the slide, we'll create a new actor and specify the value for each of the properties of that actor as we call the constructor for that actor. Notice the curly braces, that's the syntax that identifies that we're specifying those properties. We'll do it for John Travolta, a New Zealand actor, a US actor, a British actor, and one more Australian actress. And then we'll add Tom Hanks, and we won't specify a country. Now, what happens if we don't specify a country? In this case, since we're not specifying a country, and the actor class doesn't have a default value for the country property, there just won't be a value there. That's fine. We'll return the actors back. And now I'd like to retrieve a list of all the actors born in July that exist within our list of actors. Notice I've declared July actors using the var keyword. I don't know the type. I don't need to know the type. I know that it is some sort of list of actors. And now, from actor, that's our looping variable, in actors, that's our collection, where actor.birthdate.month equals 7, well, since birthdate is a date property, we can retrieve its month property. Order by actor.lastname, actor.firstname, that demonstrates you can order by multiple fields if you want. Then select actor, which returns back the entire instance of an actor that meets these criteria. Next, we'll loop through them all and display for each one of them. Notice that here I'm just using var a as my looper. I could have used actor rather than var. It doesn't really matter. As a matter of fact, you can be guaranteed that A is an actor because using generics, this query must return some sort of data structure of actor instances. You can see this works because I get to use a.firstname, a.lastname, a.birthdate, and a.country in my looping code, even though I didn't specify it was an actor. Now notice also that here inside my loop, I have to perform a calculation if I want to display the full name of the actor. Later we'll see examples where that calculation is done as part of the query itself. But for now, if I run this full speed, we'll see a list of all the actors in the array of actors that were born in July. We've talked about extension methods in general, but the underlying query class underneath our LINQ query provides a large set of its own extension methods. For example, the all method returns true if everything in the query return value matches some criteria, or any, which returns true if any item in the return set matches a criteria. There's average, there's where, you've already seen. We use the where keyword, but there's a where method, which is the result of compiling the code that includes the where keyword. There are a number of different query extension methods, and we'll use some of these as we work through our examples. Basically, anything you want to do with data, the LINQ team thought about and made sure you could do using extension methods of that query class. Now, these methods require some way to indicate the values on which they are to operate. Some of these methods have keywords, like the where keyword, in the query itself, but others don't, like the all query extension. If you want to determine if all members of the return value meet some criteria, you're going to have some way to specify that criteria and the value you'd like to pass as a parameter to test. That requires a lambda expression. A lambda expression is a method you define, the body inside the query, as a simple expression that returns true or false, at least in the all or the any case, indicating whether or not all members of the query match the criteria or any members, and all the other different methods have different syntax. But in each case, you need to have some way to specify the criteria you're testing, and that's where lambda expressions come in. Lambda expressions act as an anonymous method. In each case, you'll supply a single value and the expression return value. If you need more than one expression, well, then you really can't use it right there within the query. You'll need to create a function and call it. But the lambda expression acts as a method that you define on the fly as part of the query itself. The syntax might look something like this. Imagine you've already filled the actors collection with a list of actors and you'd like to iterate through it and display information about each actor. But you only want to do that for actors whose birth date is in September. You might write code like this to do it. You could say for each actor A in actors, of course you could have said var A in actors, either one's fine, but it's actors.where because we're now calling a method of that actors collection, which is based on the query base class, and we need to specify a parameter for that where method. The where method requires a lambda expression which defines the function we want to call for each actor. In this case, I'll refer to each actor as x, and I want to return true if x.birthdate.month equals 9. X here acts as a placeholder for each actor in turn, and the equals greater than implies that we're passing the value into this function. It's a weird syntax. It's new for LINQ, but it allows you to specify the criteria for the where method, which is an extension method on the query base class. Now, of course, we could have done this by taking our actors collection, creating a new query, using the where keyword, storing it into a new variable, and then looping through that whole collection. This one just says, I've got my actors collection, let me filter it, and loop through the results of that filter without creating a whole new collection. Let's look at an example that runs this code live so you can prove that it actually works. In our demonstration, I'll click Lambda Expressions, which takes us to our sample code. I'll step in, and this time I don't need to walk into the fill actor list procedure. You've already seen that one. I'll create the string writer for the output. And now we'll execute code which iterates through only those actors whose birth date is in September. Now, in the previous example, we created a query here, retrieved the results into a new variable, and iterated through that new list. We don't have to do this here. Here, I want to iterate through the collection of actors filtered to only those whose birth date is in September. Now remember, although it looks like this is some weird syntax, really, where is a method of actors. Now, what do we do here? I want to apply the filter to actors before I start iterating through it. The filter is, I want to take all the elements in actors, and X represents each element within that collection. And if that element's birth date month equals 9, then I want to include it in this collection. So this actually becomes a subset of the actors collection. Only those whose birth date is in September. Now we loop, letting A take on the value of each item in that collection. Well, I know there's only one in that collection. So as I iterate through now, well, at this point, I'll start over again because I edited my code. That's fine. We'll run it once more. We get to here, step into it. And now you'll see that we write out just that single actor, display the results, and you can see we get just the actor who was born in September. Now, either way is fine. If you want to use the technique you saw in the previous example, and that is you create here a new variable to contain the results and then iterate through that variable, or in the second example we looked at, use the where extension method to filter the results without creating a new variable. It's really up to you. Whatever is more convenient as you're writing your code. Every example we've seen so far returns the entire iterator variable as the return value of the select clause. When constructing your query output, you may need to restrict the return fields or even construct new fields. Rather than performing these actions when you use the data, and that would be every time you use the data, you can create a new data type at the moment you retrieve the data. That is, you can create an anonymous type, a type without a name. The syntax looks like this. As part of your select clause, you use the new keyword followed by curly braces. And then you specify the names of the fields you want in the output data structure, in this case, name and country. Name is created in this case by combining two other properties of the actor class together, and the country comes across as just the country property of the actor. The syntax involves the word new and the curly braces, and then field name equals value inside those curly braces. Now, we wouldn't be able to retrieve the birth date of an actor if we'd used a query that selected this new data structure, because we haven't included the birth date here. We could retrieve name or country for each actor. Now, under the covers, you're creating here an unnamed type, but the compiler does generate a named type, and you never see what that name is, and they refer to an instance of that named type here. It's called anonymous types because you don't know the name, and to be honest, you don't really care about the name. Let's investigate the demo that shows off this behavior. I'll click the Anonymous Types button, which takes us into our demonstration. Here we start by doing the example like we would have before. If I want a list of all the actors from the USA, and I want to later display the first name, last name, and country, I can do the work just like you've seen before. var American actors equals from actor in actors where actor.country equals USA, that filters the list for me. Order by specifies the order. I can select the entire actor. And now if I want to display just here information about, for example, the first name and last name together, I have to perform this concatenation each time I use that American actors query result. Well, let's try again. Let's see if there's a better way to do that. Here, I'll use an anonymous type. The anonymous type says select new, curly brace, name equals, and the expression I want, country equals the expression I want. Now when I use that query result, I can retrieve the name property and the country property directly. As a matter of fact, I can't retrieve any others. Those are the only two properties that have gotten exposed from this object. Okay, let's delete that, get back where we were. And now I can retrieve the name and country very simply. So you'll see that I do get the same results. I've displayed them differently, but I do get the same results. And in this case, I didn't have to perform this concatenation for each item as I used it. I performed the concatenation as I created the data structure. Before we leave the basics of working with LINQ and move on to working with data from a database, I'd like to look at some interesting examples that show off how you can use LINQ in ways that you might not think possible or you may never have considered before. Say you want to retrieve a list of all of the current processes on your computer that are maintaining more than 10 threads. Let's say you want to retrieve a list of all the words in a text file that begin with a vowel. I don't know, these are the kinds of things that programming sometimes needs to have solved. And LINQ makes these kinds of issues easier. That is, any place you need to iterate through and create a subset of a collection of objects, LINQ can come to your rescue. Let's look at the demonstration to see how you can solve each of these issues using LINQ. Let's start by listing processes. If I click the button, I walk into a procedure that does this for us. Now remember, if you've worked with the .NET framework, the process class has a getProcesses method which returns me a list of all of the current running processes. Now I can use LINQ here to filter these down. I can add a where clause that says I only want processes where threads.count is greater than 10. I can also order by threads.count, and then within processes that have the same number of threads, I can order by process name. Now I don't need all of the properties of a process coming back to me. All I care about is the process name, the working set, and the number of threads. And you'll see here I've created 3 new fields in an anonymous type to get the information I want. Okay, so we'll get that. That's fine. That's one way to do it. You can also just use extension methods of the query class to get the same thing. So process.getProcesses, I can use .where to filter that list using a lambda expression, and then .order by lets me order by anything I want. My expression is, let me pass in a variable named proc and order by proc.threads.count. But I wanted to order by 2 fields. How do you do that? Well, you use the then by method to indicate the next ordering. You can have as many of these strung together as you like. Proc passed into this expression, proc.processName, that's our lambda expression there. And notice this is just one big long expression. This is process.getProcess.where blah 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 .order by blah 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 .then by .select. So it's actually probably a little more complicated to do it this way, but we get the same exact result. We'll display on the screen the results we get. Now I've overloaded my sample display results procedure to take in, if I get a list, I display it in a grid. So I'm converting this thing I get to a list using the toList method, which is another extension method provided by that query class. And we should see in our results, in a grid, a list of all the processes whose current thread count is greater than 10, in ascending order by thread count, and within each thread count in ascending order by process name. That's pretty nice. Now how about examining a text file? Let's try this. I'm going to go browse for a text file. Here we go. And I have it right there. And that text document contains some Latin text I got off the web somewhere, some fake Latin text actually. And now we can see if the file name isn't null or empty, let's step into this procedure which is called get all words beginning with vowel. Step into that. Here's the procedure. It returns an IEnumerable of string. That's the data type I want to return back. And what does this query do? Let's see. We first read all the text from the text file into a string. There we go, and that text looks like this, a bunch of Latin stuff which isn't really Latin. And now we'll run our query to get the results we want. Look at this carefully. From word in text.split, we split that text, removing empty entries using a comma, a period, an exclamation point, or a space as a delimiter. So now we get an array where, we use our where clause now, word character 0 is vowel. Where did is vowel come from? Well, that's over in our extensions class. You'll see there is an extension method named isVowel, which returns true for A, E, I, or U. We didn't deal with Y here because that just complicates the issue. And back in our code, we can then order by word, select that word, and I add the distinct extension method to that query result, which gives me only the distinct results. Distinct doesn't require any parameters, so I don't have to specify a lambda expression in this case. So this method returns that distinct list of words that begin with a vowel, and back here in our code, we're going to iterate through that list and display the results on the screen. So here's a list, a unique list, of all the words that begin with a vowel in that Latin or fake Latin text file. Now, I would be remiss if I didn't stop at this point and mention one of the most important features of LINQ, and that is delayed execution. Just because you write a query in the code and the compiler compiles that query, and then at runtime you hit that query in the code, doesn't mean the query actually executes at that point. All the code does is create the query and make it ready to execute. LINQ queries actually don't execute until they absolutely must. For example, if you try to retrieve values, or iterate through the collection, or perform some operation, until you hit a line of code that does one of those things that actually needs the values, no action occurs. This makes it possible for you to create queries in multiple steps. That is, a query that builds upon another query that maybe builds upon another query. And it's not until you actually iterate through the values or retrieve values that LINQ will execute your query.